Welcome to lesson 7.3, squares and rectangles. You might remember from the last lesson that there are three different kinds of special parallelograms. There's rhombuses, which we learned about in lesson 7.2, squares, and rectangles. Now in this lesson we're going to learn about our other two special parallelograms, squares and rectangles. Let's start the show off with rectangles. Now remember, all of these special parallelograms are parallelograms. So a rectangle is a parallelogram, meaning it has all the properties of a parallelogram, but it's special. Like your mom, but she's special. She raised you. Be proud. The two special properties of a rectangle, and these, if it's either one of these, then we know it's a rectangle, is that one, all angles are 90 degrees. So you probably know that all the angles are 90 degrees in a rectangle. That's something you probably learned once or twice in your life. So all angles are 90 degrees. All right? So if I know that angle A is 90 degrees, angle B is equal to 90 degrees, angle C is equal to 90 degrees, and angle D is equal to 90 degrees, meaning all the angles are 90 degrees, then I know ABCD is a rectangle. All right, so that's special property number one. The second special property, and there's only two, is that the diagonals are congruent. All right, so if the diagonals are congruent, then it is a rectangle. So in this case, if I said that AB is congruent, did I say AB? Nope. If AD, which is the diagonal, is congruent to CB, well then I know that this is a rectangle. All right, so let's do a little proving. Let's do a little proofs, okay? Let's do two of them, just two. We'll keep it cool. So in parallelogram YAPS, I know that YP is congruent to AS. All right? Prove that YAPS is a rectangle. Well, right here, what has been demonstrated? Well, this means that the diagonals are congruent if these two are congruent. So I know that this is a rectangle. Okay, parallelogram YAPS is a rectangle because diagonals are congruent. All right, that's enough to prove that that is a parallelogram. Sorry, that is a rectangle. All right, in parallelogram MNOP, I know MN is perpendicular to NO. So MN and NO are perpendicular. So that means that this is a 90-degree angle. Now I also know that NO is perpendicular to OP. So NO is right here and OP is right here, and these are also perpendicular. All right, that's what this means. All right, now since I know that this is a parallelogram, I could also say that opposite angles are congruent. So if O is 90, M is also 90, and if N is 90, P is also 90, right? Opposite angles are congruent in a parallelogram. So how do I know that MNOP, this parallelogram, is a rectangle? Well, that's because all angles are 90 degrees. All right, doing pretty good. Now, over here we're going to do a little math. In rectangle CATS, we know that CA is equal to 9 and AT is equal to 12. What is the length of the diagonal CT? Well, just like in anything geometry, if you can't see it, why don't you draw a nice little picture? So let's draw our parallelogram CATS. Great name. We know that CA is equal to 9 and AT is equal to 12. I know what you're saying. That doesn't make sense. You didn't draw it right. Well, you're right. So I probably, well, whatever. We'll just keep it. We'll live with it. It'll still work out. I promise. So we're trying to find the length of diagonal CT. Now, how am I going to do this? How am I going to find this diagonal? Well, what you might recognize, is that what we have here is a 90-degree angle. And so over here, just like we learned in the last lesson, we can find ourselves a right triangle. And in a right triangle, we could always use the Pythagorean theorem to find our missing side with this CT. So I could say that 9 squared plus 12 squared is equal to x squared. And of course, since x is the missing, across the 90 is x. That's why I put that for C. 81 plus 144 is equal to x squared. 225 is equal to x squared. Take the square root, we get 15 is equal to x. All right, so CT, our diagonal is 15. Remember, if you can find these right triangles, you can use the Pythagorean theorem to find missing sides. Nice. Now let's look at the properties of a square, and this is pretty important to know. So a parallelogram is a square if it has the properties of a rhombus and a rectangle. So a square is really just a rhombus and a rectangle smushed together. So if you know the properties of a rhombus and you know the special properties of a rectangle, all you have to do is take one of each to make a square. So let me show you. Let's recall our properties of a rhombus. What are they again? Well, let's see. All sides. And you should try to do this by yourself, by the way. Try to pause the video and do it by yourself. It's good practice. But I'll do it for you now. But I say pause the video and do it by yourself, but I'll do it with you now. So all sides are congruent is one of them. We know the diagonals are perpendicular. And I know that the diagonals bisect the angles. So these are my three rhombus properties. Now the rectangle properties we just learned. So that's all angles are 90 degrees. All right. And also the diagonals are congruent. So for something to be a square, it needs to have one property of a rhombus, so that proves that it's a rhombus, all right? So one rhombus property, and it also has to have one rectangle property, so it has to have one rectangle. So if it has one of these and one of these, it is a square, so it has to have one of both, right? So if all sides are congruent, so that's a rhombus property, and the diagonals are congruent, well, then we know that this must be a square. All right, so it has to have one. I guess what I was trying to write here. Let me be a little more clear. Let's write this in together. It should have one property of both. One property from both, and only one. But it has to have one from both to be a square. So that will prove that's a rhombus, and that'll prove that's a rectangle. All right, so let's prove that these are squares, okay? In parallelogram ABCD, we know all sides are congruent. Well, that's pretty easy. All right, and we know that AC is congruent to BC. All right, so we want to prove that this is a square. Well, I know parallelogram WXYZ is a square because, well, I know all sides are congruent. All right, and the diagonals are congruent as well. So since all sides are congruent and the diagonals are congruent, it must be a square because it has one rhombus. This is our rhombus property. Rhombus, and it has one square property. One rectangle property. All right, so it has one of each. So that means it must be a square. All right, so let's try another one. In parallelogram WXYZ, WY is perpendicular to XZ. So WY is perpendicular to XZ. All right, so that's a 90-degree angle. We also know, sorry, they're all 90 if it's perpendicular. We also know WY, all right, that's the diagonal, is congruent to XZ. Prove that it's a square. Well, let's see, parallelogram WXYZ is a square because, well, number one, we know that the diagonals are perpendicular. All right, and that's my one rhombus property. That's from a rhombus. And I also know, and diagonals are congruent. And that's my one rectangle property. So as long as I have one from both, I know that it must be a parallelogram. And let's try this last one. All right, we're going to be filling out some angles. Parallelogram ABCD is a square. Fill in the missing angles and state the properties used to find the missing angles. And I know what you're doing. You're looking at this and saying, well, there's no angles. How is that possible? Watch and learn, little fella. The first angle we're going to find is DAB. And yup, that means dab. I hope you're dabbing right now. So that's this angle right here. Now, the DAB we know is 90 degrees because in a square, remember, it has all the properties of these two. So since a square is a rectangle, we know all the angles are 90. All right, all angles are 90 degrees in a square. So 90 degrees for DAB. Reason? All angles are 90 degrees. All right, now I want to find DAC. That's this angle right here. Now in a rhombus, you might remember, the diagonal bisects the angles. All right, the diagonal bisects the angles. Remember that one? So if this whole angle, oh, come on, follow me down. If this whole angle is 90, which I'll label here, that's the whole angle. If the diagonal bisects in half, that means this must be 45 and this must be 45. Okay, so this is 45 degrees. And the reason we know that is because the diagonals bisect the angles. And then finally, I want to find AED, which is right here. Now, once again, I'm going to say this. A square has all the properties of a rectangle and a rhombus. It has all the same properties. So I know that the diagonals make a 90-degree angle. So AED, which is right here, this is a 90-degree angle. What is going on? This is just the ugliest thing. This is like your face. Ooh, dissed ya. But seriously, this is a 90-degree angle. AED is 90. And why is that? It's because the diagonals are perpendicular. So don't forget, guys, a square is special because it has all of the properties of a rhombus and a rectangle. All right? Now let's do a few last proofs. Okay, let's work on some challenge problems right now. All right, now we're going to determine. So we're going to do a full review. We're going to, based on the information given, we're going to determine if the following quadrilaterals are a rhombus, a rectangle, or a square. All right? So in quadrilateral ABCD, we know that AC is perpendicular to BD and angle A is 70 degrees. So let's draw this out. All right? So this is our quadrilateral, and this is A, B, C, D. All right? So angle A is 70 degrees. And we know that AC and BD are perpendicular. What kind of quadrilateral is this? Is this a rhombus, a rectangle, or a square? Well, the two facts we have is one, we know the diagonals are perpendicular. So that means it must be a rhombus, all right, at least. Now, it could also be a square because a square has all the properties of a rhombus. But since angle A is 70 degrees, all right, and not 90 degrees, we know that this must be a rhombus. And that's because diagonals are perpendicular. All right, and we also know that angles are not 90 degrees, so it's not a square. All right. Now, if that was 90 degrees, this would be a square because that would also be the property of a rectangle. It'd have one square and one one rhombus and one rectangle property. But since it's 70, we know this must be a rhombus. It has the special property of a rhombus. Let's try another one. What information would prove a parallelogram is a rectangle? Okay. So we want to find one of the special properties of a rectangle here. We have 4. The first one is diagonals bisect the angles. All right, and this property, you might know, is a special property of a rhombus. All right, that's a rhombus property. Diagonals bisect the angles, that's a rhombus. So that doesn't work for rectangle. Opposite angles are congruent. Well, that's true for a rectangle, but that only proves that it's a parallelogram. All right, that's not one of the special properties. That's a parallelogram property. All angles are right angles. Well, that looks pretty good, but I'm going to skip to the next one. And all sides are congruent. All sides are congruent. That's a rhombus property. And I'm thinking this guy. All angles are right angles. That is our rectangle property. So that is the special property of a rectangle. The answer is number 3. So in doing these, it's good to write what property these relate to. So if this is a rhombus property, draw a little arrow and say it's a rhombus property. It'll help you answer these questions. These come up a lot, okay? I'm warning you. All right, so what information would prove that a parallelogram is a square? So that to remind you, that means you need one rhombus property. To prove it's a rhombus, you need one rectangle property. So we're going to do what we just did in the last problem. We're going to label where these properties belong to. So let's go through these, okay? We need one rhombus, one rectangle for it to be proven a square. The first one, it says that opposite sides are congruent and diagonals are congruent. Opposite sides are congruent is a property of parallelograms. All right, that's from parallelograms. And diagonals are congruent. That's from a rhombus. So that is not enough to prove it. That's parallelogram rhombus. We need rhombus rectangle. Let's go on to the next one. Diagonals bisect each other and all angles are right angles. Diagonals bisect each other, not the angles, but just each other. That's a parallelogram property. And I'm pointing out that it's each other and not the diangles because I actually just recorded this. I messed this up, so I just want to be clear. That's a parallelogram property. And all angles are right angles. That's a rectangle property. So this is parallelogram rectangle. Nope, we need one rhombus, one rectangle. The next one says opposite sides are parallel. Well, guess what? Oh, and diagonals bisect the angles. So this is once again a parallelogram property. And this is a rhombus property. Nope, that doesn't meet our criteria. And then it says diagonals are perpendicular. You know what? I want to use a different color. Diagonals are perpendicular and all angles are right angles. Well, this is a rhombus property. And this is a rectangle property. So we have one rhombus, one rectangle, and that would be our answer. All right, one rhombus, one rectangle. That means it must be a square. All right, so you're going to do a bunch of questions like this, so I just want to go over a few with you. For which quadrilaterals, parallelogram, rectangle, rhombus, or square, are the following statements true? The first one says opposite sides are congruent. All right, well that is true for parallelograms. All right, but you might remember rectangles, rhombuses, and squares, those are all parallelograms. So opposite sides are congruent is true for all of these. All right, that's also true for rectangles. That's also true for rhombuses. And that's also true for squares because they are all parallelograms. All right, diagonals are congruent. Well, that's a special one for rectangles. All right, that's not true for all parallelograms. And that's not true for all rhombuses. But since a square is a rectangle, it's also true for squares. All right, that's another long lesson, but you finished. So hopefully that helps. And yeah, you know, summer's coming up, guys. So just watch what you eat so you get your beach bod going. It's a little tip for health. You're welcome.